Good morning, ladies and gentlemen. My name is Aiyelaagbe. I work for the Department of Horticulture, Federal University of Agriculture, Abeokuta in Southwest Nigeria. I'm making this presentation on behalf of my other colleagues, Amina Oyeniyi and Sulaiman Adedeji. And the title of our presentation is Adaptive Fluted Pumpkin for Greenhouse Cultivation. How much water do the plants need? Fluted pumpkin, and that's the photograph inset of what it looks like, is a traditional leaf vegetable in the family Cucurbitaceae. It is a facultative perennial and has a tendency to climb when it has support. And when all the conditions of water, light, nutrients are optimal, Telfairia occidentale has the capability to extend beyond one growing season, regularly supplying the grower fresh supplies of nutritious vegetables either for table or for sale. And fluted pumpkin is endemic in the humid forest zone of southeast and south-south Nigeria, where it features prominently in the cropping systems and especially in the intensively managed home gardens that subtend the various homesteads. This vegetable is cherished for its nutritive and health values, which are induced by the phytochemical content of the leaves and the seeds. Over the years, the demand for fluted pumpkin has increased astronomically and currently demand outstrips supply. And why is this so? That's because in the first instance, not enough land is being put to the cultivation of fluted pumpkin. Number two, the current technology for production in the open field is still suboptimal. And number three, even this suboptimal production is further impaired by the dry season, which lasts for 5 months of the year. And during this period, there is soil moisture stress, which prevents most of the farmers, about 70% of them, from continuing with the cultivation of fluted pumpkin and limiting those who are willing to do so to the residual soil moisture in the inland valleys. And the question before us is, how can we enable the growers to key into this opportunity provided by the gap between the demand and the supply of fluted pumpkin? This would require a system that guarantees all the year production of high quality produce through intensification. And this need is best met by greenhouse cultivation. However, hitherto, there has been no one who has explored this possibility. Our group thinks that Telfairia occidentale can be upgraded to a crop for the greenhouse, and our vision is to provide all the technologies that will help you to transit from field cultivation into greenhouse cultivation so that the supply gap can be met. Specifically, the study that is being reported today addressed the question, how much water do these plants need? To achieve this, a greenhouse study was conducted at the Federal University of Agriculture in Abeokuta in 2008 and 2012. Both studies were conducted during the dry season. 3-week-old seedlings were transplanted into poly bags containing 6 kilograms of sandy soil, and in the following year, the amount of soil was increased to 10 kilograms based on our experience in the previous trial. Since the soil was impoverished, the nutrient content was boosted by the application of 1.5 kilograms of poultry manure in the first year and 2.0 kilograms of poultry manure per plant in the second year. The seedlings were laid out on a 0.5 by 1 meter grid and trained onto polyethylene strings that enable them to maximize space by growing towards the roof. Each seedling thereafter received 0.25, 0.5, 0.75, and 1.0 litre of water per week. The irrigation rates were assigned following a completely randomized design replicated 4 times. The soil moisture status was monitored gravimetrically, and plant growth was assessed, tracking vine growth, leaf production, and total dry matter production. The nutritive effects, or rather the response of the nutrient content of these plants to the irrigation rates was monitored by assessing vitamin A, nitrogen, phosphorus, potassium, calcium, and magnesium content of the leaves. I present to you the nutrient status of the soils used and also the response of vineland to the irrigation rates. We see that in 2008, application of 0.5 and 0.25 litre of water per plant per week significantly curtailed the growth of the vines when compared with plants irrigated with 0.75 and 1.0 litre water per plant per week. The same trend was repeated in 2012, and there you find 2 clusters mainly, those that were irrigated with 0.05 and 1.0 litre water per plant, which were significantly longer than plants irrigated with 0.25 and 0.5 litre water. More or less the same trend was repeated with regards to leaf production, the only difference being that in plants cultivated in 2008, the effects of 0.75 were at par with those of 0.25 and 0.5 litre water per plant per week. However, plants irrigated with 1 litre of water per week produce significantly more leaves than those irrigated with 0.25 litre water per week. In 2012, we see more or less 2 clusters. One cluster consists of the plants that were irrigated with 0.75 and 1 litre water per week, which produce significantly more leaves than plants irrigated with 0.25 or 0.5 litre water per week. We looked at dry matter accumulation, which is a good index of photosynthetic capacity of the plant, as it gives a clue to net photosynthesis. In the 2008 trial, we found that irrigating with 0.25 litre water per plant per week significantly reduced dry matter accumulation compared with higher irrigation rates. The effects of 0.5 and 0.75 did not differ significantly, but plants irrigated with 1 litre of water per week had significantly more dry matter than plants irrigated with 0.5 or 0.25. Nonetheless, the effects of 0.75 litre of water per week were at par with those of irrigating with 1.0 litre water per week. In 2012, there was a slight difference. The effects of 0.25 and 0.5 litre of water per week did not differ significantly, and similarly, the effects of 0.75 and 1.0 were at par. However, plants irrigated with 0.75 and 1.0 litre water per plant produce significantly more dry matter than the lower irrigations. If you take a look at this slide, you see that dry matter accumulation, or rather partitioning into the plant parts, followed the same trend. Most of the dry matter was partitioned into the leaves and the vine, and that's good news because the leaves and the tender vines are actually the economic portion of the plant. In both years, the trends were the same, and this gives us a clue that with good irrigation, the nutrient content of the plants can be increased. But as with the previous parameters, you find here that the difference between 0.75 and 1.0 litre of water per plant per week was often not significant. Whereas in the case of dry matter accumulation, we had this nice. When it came to vitamin A content, the vitamin A content of the leaves was not in any way significantly affected by the irrigation rates. The data is not shown here. Nonetheless, the content of nitrogen, phosphorus, potassium, calcium, and magnesium increased progressively with the application of increased water rates, giving a clue that appropriate irrigation will enhance nutrient uptake. The exception to this was in 2008, where potassium content peaked after 0.5 litre water applied per plant per week. So all said, we think here that the best options when it comes to the nutritive content of the leaves is achieved when you irrigate with 1 litre of water per plant per week. At the end of the study, what's our take home? First, we know that irrigation affects the growth and net photosynthesis of fluted pumpkin. We believe that the best results are achieved when you irrigate with either 0.75 or 1 litre. But from the economic point of view, since the effects of 0.75 and 1.0 litre water per plant per week are often apart, we'd like to recommend that growers in the southwest Nigeria who want to adapt fluted pumpkin for greenhouse cultivation should consider applying 0.75 litre water per plant per week. However, a word of caution, this recommendation covers only the early vegetative growth stage. It is likely that as the plant advances in age and the roots ramify the potting media, the extractive power of the plants will be increased. Nonetheless, this hypothesis needs to be subjected to verification, and sincerely, that's outside the scope of this work. And so we say, for starters, at the early vegetative growth stage, 0.75 litres of water per plant per week will suffice to give an economic crop of fluted pumpkin grown in the greenhouse. Here are useful references. Thank you very much.